Section 12.7 is applications with rational expressions. Most problems can be set up using a table, which will help you solve those. There are two different types of distance, rate, and time tables or problems. The first one, you will have one unknown value and a second unknown value. And you will know distance, rate, or time. It'll just vary on what the problem is. But what you need to fill in is what you know in the table. So do you know the distance? Do you know the rate? Do you know the time? And the reason I have distance over rate in that area is because the majority of the time you're going to be changing time into distance over rate. The other problems that involve distance, rate, and time are problems where you are going with the wind or against the wind. So there, they typically give you a rate in still air or still water. When you're going with the wind, you would take that rate plus W. When you're going against the wind, that's the rate minus W. And then once again, you're probably going to write that as distance over rate for your value of time. The third type of problem that is easily done with a table is when you have a work problem. For example, it takes me 2 hours to cook dinner. It takes my husband 1 hour to cook dinner. The time for me to complete the job would be 2 hours. The time for him to complete the job would be 1 hour. You have to figure out your rate or your work per hour. So that's 1 over the time it takes you to complete your job. And then usually when there are problems like this, if you're working together, if you do it together, it takes less time. But you can't simply add together the time it takes me and the time it takes my husband and get the time it takes us together. Because the whole point is if two people are working together to do something, those times are not going to add up. You're going to be somewhere between the two as far as how long it's going to take you to complete the job. We're going through examples now, and there is a copy of this worksheet in Canvas in module week 2A. So if you have the ability to print that, I would recommend that you do that. Otherwise, you can just follow along here. I know sometimes it takes a little bit of time to write out problems. That is why I went ahead and typed them and gave them to you in that form. I think you will find the word problems in this chapter will be some of the easiest word problems that you've experienced. Remember, we are in a chapter where we're dealing with rational expressions or ratios or fractions, so just get in the habit of knowing that what you're going to have are going to be fractions. That's the whole point. I did go ahead and set up a table for this first example. It doesn't have to be done with a table, but it certainly can be. Example 1, one number is 1/3 of another number. The sum of the two numbers is 16. Find the two numbers. I've got my table. The first variable is number 1. The second variable is number 2. If I call number 1 x, then the other number is 1/3 of that number, 1/3 x, which ends up being x over 3. Now I'm going to take this sentence here that says the sum of the two numbers is 16. Number 1 is x, plus number 2 is x over 3 equals 16. And I'm going to solve this problem. Notice I have x over 3, that's giving me my rational. And when I have a number in my denominator, I need to find my least common denominator, which in this case is 3. So I will multiply everything by 3. 3 times x is 3x. 3 times x over 3 is going to be x. 3 times 16 is 48. 3x plus x is 4x equals 48. Divide both sides by 4. X equals 12. Coming back up here in my table, number 1 is x. That's the number 12. Number 2 is 12 over 3, which is 4. So my two numbers are 4 and 12. And 4 plus 12 is 16. 1/3 of 12 is 4. So checks. Here is our second job, which I tried to explain when I was going through the notes. It's a little bit more complicated, just explaining it without an example. This is an example of a problem where we're talking about work. Craig and Cindy, working together, can rake the yard in 6 hours. Working alone, Cindy takes 3 times as long as Craig. How long does it take Craig to rake the yard? I have Craig, Cindy, and together on the left-hand side of my table. Across the top, second bar over, I have time to complete job. Third bar, my title is work done in 1 hour, which we consider 1 over the time to complete the job. And now you go back to the word problem and start filling things in. Craig and Cindy working together can rake the yard in 6 hours. So in the together column, I'm going to put in there 6. Working alone, Cindy takes 3 times as long as Craig. If I call Craig X, Cindy would be 3x because that's 3 times as long. Remember I told you when we were going over the notes, you can't add the time to complete the job because the whole point is doing things together should shorten the time. That's why the work done in 1 hour is so important. We have to find that rate. Craig's rate is 1 over x. Cindy's rate is 1 over 3x. And the rate together is 1 over 6. Once I know how much work each one does in an hour, it will make sense to add those together. So my equation is going to be 1 over x plus 1 over 3x equals 1 over 6. My least common denominator is going to be 6x. When I multiply everything times 6x, I've got 6x times 1 over x plus 1 over 3x equals 1/6. 6x times 1 over x gives me 6. 6x times 1 over 3x gives me 2. 6x times 1/6 gives me x. 6 plus 2 is 8, so x is 8. That is how long it takes Craig. Cindy takes 24, 3 times as long. It is asking me how long it takes Craig to rake the yard, so the answer is 8 hours. And yes, it is as simple as just adding 6 plus 2. As I said, these problems will be some of the easiest problems you've probably ever done. Example 3. The denominator of a fraction is 3 more than 3 times the numerator. If both the numerator and denominator are increased by 6, the simplified result is 4 over 9. Find the original fraction, do not simplify. So the numerator and the denominator are what I need to determine here. The denominator of a fraction is 3 more than 3 times the numerator. So if I call my numerator n, my denominator is 3 more than, that means I'm adding 3 times the numerator. So with my original fraction, my numerator was n, my denominator was 3n plus 3. My numerator and denominator increased by 6. Increasing by 6 means adding 6. So my new fraction for my numerator is going to be n plus 6. For my denominator, it will be 3n plus 3 plus 6, which simplifies to 3n plus 9. And it says that that fraction, when I simplify it, is 4 over 9. That's the equation I'm going to solve. N plus 6 over 3n plus 9 equals 4 over 9. I'm going to cross multiply. 9 times n plus 6 is equal to 4 times 3n plus 9. 9 times n is 9n. 9 times 6 is 54. 4 times 3n is 12n. 4 times 3 is 36. I'm going to subtract 9 and subtract 36 from both sides, and that's 9n, not just 9, I apologize. 9n minus 9n is 0. 54 minus 36 is 18. 12n minus 9n is 3n. 36 minus 36 is 0. I have 18 equals 3n. Divide both sides by 3. N is equal to 6. Coming back up here, if n is 6, then that's my numerator. My denominator is 3 times 6, which is 18, plus 3 is 21. So my original fraction is 6 over 21. And I do not want to reduce. It could reduce, but it told me not to. So I'm going to leave it just like that. Example number 4, an airplane can travel 490 miles per hour in still air. If it travels 3,018 miles with the wind and the same length of time it travels 2,862 miles against the wind, what is the speed of the wind? Again, I like to use a table. I have two situations, with the wind and against the wind. I have distance, rate, and time, which I am going to call time equaling distance over rate. I'm going to go back and I'm going to plug in what I know. I know that the rate in still air is 490 miles per hour. So the rate with the wind will be 490 plus W. The rate against the wind will be 490 minus W. If it travels 3,018 miles with the wind, my distance here is 3,018. In the same length of time it travels 2,862 miles against the wind. For my time, I'm going to put in here distance, so 3,018 divided by rate, which is 490 plus W. For against the wind, it's distance, which is 2,862 over the rate, which is 490 minus the wind. And it says the length of time is the same. So I'm going to take these two representations of time and set them equal to each other. 3,018 over 490 plus W equals 2,862 over 490 minus W. Once again, I'm going to cross multiply. 3,018 times 490 minus W equals 2,862 times 490 plus W. If you don't have a calculator out, now is a time where I would highly recommend it because these will be big numbers. 3,018 times 490 is 1,478,820. 3,018 times a negative W is minus 3,018 W. 2,862 times 490 is 1,402,380. 2,862 times W is plus 2,862 W. I am going to add 3018W to both sides, and I'm going to subtract 1,402,380 from both sides. On the left, that leaves me with 76,440. On the right, it leaves me with 5,880 W. I'll transfer that up here. 76,440 equals 5,880 W. Divide both sides by 5,880. And W equals 13. So the wind is traveling 13 miles per hour. And that's what it wanted to know. What's the speed of the wind? Example number 5. John recently drove to visit his parents who live 540 miles away. On his way there, his average speed was 11 miles per hour faster than on his way home. He ran into some bad weather. If John spent 18 hours driving, find the two rates. My two situations are to the parents, from the parents, and I have a total. I have distance, rate, and time, which again I'm going to use as distance over rate. And I'm going to start filling in what I know. John recently drove to visit his parents who live 540 miles away. That's the distance, and I think that's the distance to his parents and home from his parents. I don't know that total is important, so I'm going to leave that blank for now. On his way there, on his way to his parents, his average speed was 11 miles per hour faster. 11 miles per hour faster means plus 11. So to his parents, his rate was R plus 11. On his way home, he just drove R. Total time spent driving was 18. I'm going to put that over here. Nothing's going to go there and nothing's going to go there. The time to the parents is 540 over R plus 11. The time from the parents is 540 over R. And those two amounts, 540 over R plus 11 plus 540 over R, equals 18 hours. My lowest common denominator is going to be R times R plus 11. R times R plus 11 times 540 over R plus 11 plus 540 over R equal 18. When I take R times R plus 11 times 540 over R plus 11, I'm left with 540R. When I take R times R plus 11 times 540 over R, I'm left with 540 times R plus 11. And when I take R times R plus 11 times 18, I'm left with 18R times R plus 11. Now I'm going to need to distribute, keep the 540R, add another 540R. 540 times 11 is 5,940. On the right-hand side, I have 18R squared plus 198R. On the left, when I gather like terms, I have 1,080R plus 5,940 equals 18R squared plus 198R. I'm going to need to transfer this to another page. Ran out of room. I have 1,080R plus 5,940 equals 18r squared plus 198r. There's where it was. I've got an r squared term, so I'm going to set this equal to 0. So I'm subtracting the 1080r and I'm subtracting the 5,940 from both sides. It leaves me with 0 equals 18r squared minus 882r minus 5,940. And typically, that leading coefficient is a common factor, and in this case it is. 18 goes into all of those evenly. That leaves me with r squared minus 49r minus 330. It's a little bit smaller number. Remember the t-table. We're looking for two factors of negative 330 that when we add them together give us negative 49. 10 times 33, 11 times 30, 15 times 22, 5 times 66, 6 times 55. And in this case, the bigger ones have to be negative. I think this is the combination. Negative 55 plus 6 gives me negative 49. Zero equals 18 times r minus 55 times r plus 6, which means r is either 55 or r is equal to negative 6. Now we're talking about rates, which means I cannot go negative miles per hour. I will throw out this solution. And the problem is asking if John spent a total of 18 hours driving, find the two rates. R is 55. R plus 11, 55 plus 11 is 66. So our two rates are 55 miles per hour and 66 miles per hour. Here's our final example. It's another work problem. It takes Philip 3 hours to proof a chapter of Hawk's Learning System college algebra book, and it takes Mandy 7 hours. How long would it take them to work together? Round your answer to the two decimal places. So I have Philip, Mandy together. It takes Philip 3 hours. It takes Mandy 7 hours. I don't know how long it takes them to get working together, so I'll call that X. Philip's work rate is 1 over 3. Mandy's is 1 over 7. Together it's 1 over X. So I have 1/3 plus 1/7 equals 1 over X. The lowest common denominator is 21X. When I take all of this times 21X, 21X times 1/3 leaves me with 7X. 21X times 1/7 leaves me with 3X. 21X times 1 over X leaves me with 21. 7X plus 3X is 10X equals 21. Divide both sides by 10. X equals 2.1. And once a rounded answer to two decimal places, 2.10 hours. That concludes the 12.7 notes.